When we want to talk about high dynamic range imaging, then we have to talk about the quality. And the simplest way to talk about quality in dynamic is to first make a definition. What is the dynamic and what quality can have that dynamic? So when we have here our curve or our graph, again, it's pretty much the curve that we have in Photoshop, where we have here our input and here our output. So what is the input? The input here could be the reality, of course. Real. There we have here the sun. And then on the other side here 0. That would be absolute black on this point. If that is possible, we could argue about that. So the simplest way would be just to take a line here, straight, and then the sun goes here over to this side and is then in the output side exactly the sun. Is that possible? Yes, it is. But to have here exactly the sun means that we have to capture a lot of data to get finally this. The saying is normally, and that is roughly simplified and everything else then precise, a candle and the sun is a ratio of 1 to 1 million. So okay, maybe it's 1 to 5 million or maybe only 500,000. That's not so important. The sun changes its strength, of course, based on atmosphere, distance, and so on. What is important is how much dynamic we need to represent the world in the best way in our scene files. And if it is 1 million or 10 million, I think it doesn't matter, because it's a small point. What is more important is the reflection of the sun to the scene. So we have here maybe an interest of a dark value in this area, whatever comes in, and maybe we have a value like here, and that is not really a nice relationship to the sun. So we have maybe an interest in a dynamic from here to here. The dynamic itself is exactly this area here, minimum and maximum. We could have the sun, of course, in it, but we will see it's only a small spot. And to capture this amount of data here, I make that a little bit clearer, this dynamic here, we need maybe already 9, maybe 13 shots with a good camera. The less dynamic the camera has by itself, the more shots we need. And so this is maybe a rule of thumb. When a camera has 12 stops, then we put maybe 9 or 13 images with 1 stop apart into it, and then we can say we get this light in, and we want to have maybe then an curve that goes from here to here pretty straight. Okay, let's make that straight. And then we have here our maximum, and that would be our image. So reality in, image out. And the better we have here values along the line, the more we have, the more differentiation we have, and the better it is. There's one thing that we have to consider. In this area here, most cameras produce noise. When we have noise, we have no clear border here. Noise means that we shrink our dynamic range, and sometimes pretty drastically. When we have clipped values in our HDRI, then we have not really an HDRI, then we have something that is not really there. Of course, the sun will be always clipped. But what we try to do here is to have the darkest and the brightest area here. And I want to show you that, of course. When we take photos for an HDRI, we take several shots, always 1, 2, 3 exposure values, EV values apart from each other, and then we combine them. We will see how that goes in the practical part, how we capture those things. So here we see we have always a raw image and a JPEG. I like to have both here. It's easier sometimes to have a preview with the JPEG, what it's all about. but the raw information is always the golden standard. JPEGs have distortion in it. So here we can see we have already 9 images, 9 different images, 18 at all, always 2, so 9 different exposures. That's not bad. And we can scroll here down, and then you will see we have here even more. When I go here from the darkest one, where we have nearly no information, and I could have taken a darker one, and then up to this image here, that means we have here 13 different stops of light into it. All of that goes then into an application that can merge all of these values to one image together. The less images we take and the larger the parts are between these pictures, the less the quality is. And I want to show you that on an example, of course. The example is twofold, a bad one and a good one. So the first idea is, of course, to show the good one, so you have an eye for the bad stuff. The first step that you can do when you get an HDRI is to go in Photoshop here to this slider. When you can't see it, it's here in the 32-bit exposure. And to just go slowly down, and you see already how far you can go, and then to go slowly up with it, and then you see how these values develop each other. And you see here in the corner where the shadow is, there we have, even when everything is blown out, no details. Details means when I can differentiate between things. And the more smooth this goes here, especially here on the sky, you can see that, where we have not so different values finally, the more details I have, the more differentiation I have. Okay, double click here to bring it back, and now comes the bad one. Looks on a first glimpse not so much different, but, and I switch this here off so you know exactly I'm not cheating here. When I go now here, you see here we have already an edge. It's not very smooth. I show you that in comparison. Very smooth here, very hard here. There's a little difference in it, because when you want to show a bad example, you don't get it really that bad and exact in the same way than the good one. So you have the same dynamic here. It stops here pretty much on the same spot than the other one, and I can crank it up until here, and you get even here the light in the same way, so it's comparable. But let's have a look to some details here. So when I go here to that house and I move it up and down, you can recognize that there's a house, but in the moment I switch this off and show you the better version, then you see there's so much more detail in it. And I admit this is an extreme value and an extreme bad one on the other hand. So we can crank it up without losing details in the middles and so on. This is maybe an example very, very apart from each other, very bad and something very acceptable. This is the first step that I always do when I get something in my hands. And then there is a very bad trick to get out of bad stuff, out of bad exposed areas, even a super high dynamic. It's as simple as that. You just make a copy out of that, and then you put this here to multiply. And then you get a huge dynamic range, and the ratio between the highest and the lowest is something like when it was before 4700 to 1, which I measured here, then it's something like 2 millions or something like that. And you can see here there's a lot of stuff in it, and especially when you have the sun inside, it goes really like an explosion then. Anyway, I think you got clear about the quality, and the more exposures you have in the middle, the more details you can differentiate with the slider here. With this one I can't. And there is pretty much the quality in it. So it's not only the dynamic, it's also the differentiation inside of the picture that makes the quality. And this one here will give not a good global illumination or image-based lighting source. The other one will, and that's the beauty of it. But on a first glimpse, it's maybe not that visible. Okay, just a little test. What is possible? I stay here in Photomatix Pro number 4.2, and we can have here an HDR histogram. And this gives some values here on your hand, and you can see here that we have values from 0.2 to 99.95, which excludes most of the time just when there is some black in the picture, like the frame of the fisheye here. And of course it excludes the sun most of the time, which is exactly here. The last number is mostly the sun. And you can see here we go from pretty much here where 0 is, then up to this value. We have nearly 20 stops inside of that. Relative log to 2 is pretty much a stop. So far I understand the world. And we have here a dynamic range of 4800. When I close this and I go then here to my good picture and I use here the histogram again, I can see here that my estimated dynamic range is higher, and I have here pretty much the same values in it, +9 and so on. But as I said, we have here way more information, and you can go here to tone mapping and you will see immediately that you get all these details here. And when I switch this for a moment off and I go here to my bad one, oops, I go here to my bad one and click here on tone mapping, then there is no differentiation in it. It's just a gray soup here. There's nothing to differentiate. Even Photomatix, I would think, gives just up here. There's even strength to full and detailed contrast. There's nothing really in it, in the picture. Okay, I hope that gave you a short introduction to how to evaluate an HDRI. We will see more of that. I will talk a little bit about that we shoot in different exposures, not only based on the limitations of the sensor. Also the lenses might not be able to really give you the HDRI that you want to have in one shot, because there's also a resolution in the lens, in the sensor, and everywhere else. So this is only a head start, and I hope you got already a nice impression about where we are going. Thanks for listening. See you in the next part.